Hey everybody, Mr. Judson here. Hey, so I'm really sorry about this week, you guys. I haven't been able to be there during class time. Just to let you know, my mom's not doing real well. She's declined at a pretty fast pace, and so that's really my focus for this week. I'm trying to do the best I can to still give you guys things to do to keep us moving forward, but that's kind of where I'm at. So anyway. I've got a quick lesson here for you on trying to change trig expressions to equal something else, and so we'll work on that today, and hopefully next week I can get back to being with you guys and helping out and stuff. So thanks for understanding. I appreciate it. We'll see you soon. All right, let me get you today's lesson. Okay, here we go. So for today, what we have is, I call it almost like puzzle solving. You know, we're trying to verify that something is true. And excuse me, what the directions will say is they want us to transform the left side into the right side, which means make this right here look like this. Okay, change the left side so that it looks like the right side. And there's a couple rules that we have to follow when we do this. First rule is you can only work with the left side. You can't do anything to the right side. We have to work with this until we get this to equal 1. All right. The second thing is we have this list of identities that we've talked about, and we also had our negative angle identities. You know, where if you have a negative angle, we consider this a messy angle. I want to change this into something else. Okay, so you should have this written in your notes somewhere. It's also on the front cover of our textbook. So, you know, this page right here has all of our identities. We've talked about these reciprocal identities, the quotient, which I call tangent and cotangent identities, Pythagorean theorem, and then the negative angle identities. Those are the only ones we've talked about so far. So the rest of them don't mean anything to us. But, you know, take a picture of this if you'd like. Also take a picture of this. And then also remember that we highlighted, you know, like which ones were considered most important. And it's because one of our general rules when we're trying to transform this is if you don't know what to do, change things to sines and cosines. It almost always helps. All right? So, you know, I can see a tangent changing to sines and cosines, a cotangent, cosecant or secant changing. You could do that as well. All right, so let's do a couple of these together first. So, you know, first of all, I'm looking at this side right here, and you guys got to remember this. At any point, if you go, I don't know what to do, well, then you do know what to do because you want to change things to sines and cosines. We've got to at least make it that far, okay? So I know that a secant is equal to 1 over cosine. See, there it is right there. Secant equals 1 over cosine. So if I write that down, cosine theta times 1 over cosine theta, well then when I look at that I see that those can cancel because we're multiplying. Remember, that's the only time you can cancel is when you're multiplying two fractions. This is the fraction over 1, so I'll cancel those. And I also want to remember, when I say cancel, what I really mean is this divided by this equals 1. And so I'll put a 1 in both of those spots. And so, you know, now what I have is 1 times 1 is 1 over 1. That's just 1. And what I usually do is I just circle it and go, yep, that's what I was trying to get. All right, let's try another one. All right, so here's another one. We're trying to transform the left side into the right side. Okay, make this look like that. Well, if you look at this and you go, I'm stuck, I don't know what to do, well, that means we should change the sines and cosines. Well, that's not very helpful this time, right? We already have sines and cosines. So, I mean, the only other thing is, really, let's just multiply it out and see what happens. Okay? So if I FOIL this, I'm going to get 1 minus a sine theta and then plus a sine theta, and then minus sine squared theta. All right, so when I add these like terms together, so these trig functions, they're considered like terms because it's the same trig function, they're both sines, and they both have exactly the same angle. If I don't have the same trig function, the same angle, I can't add those together. So those are opposites, so they're going to add up to 0. And so what I get now is 1 minus sine squared theta. So here's another strategy. Anytime you see exponents of 2, that means it probably has something to do with one of these Pythagorean identities, right? None of the other ones have that. Okay, it's not a guarantee that it has to do with this, but most likely it does. Okay, so what I'm going to do is I'm going to come off to the side here and do my chicken scratch thing where I say sine squared plus cosine squared equals 1. And I go, all right, well what I have here is 1 minus a sine squared, so let's move the sine over to this side. So I get sine squared equals 1 minus, cosine squared equals 1 minus sine squared. So we just took this piece, moved it to the other side, and did the opposite. So all that does is off to the side, it's telling me that this is really equal to a cosine squared. And there it is. That's what I was trying to get to. All right, let me give you guys one to try. All right, you guys go ahead and try this one. So here's a good example of where maybe it's not best to change everything to sines and cosines, but at the same time, there's nothing wrong with doing that. We just need to pick something and try it. So let's just say somebody did that. They changed everything to sines and cosines. So I've got 1 plus. I know a tangent is sine divided by cosine. So tangent squared would be sine squared of theta over cosine squared theta divided by sine squared theta plus cosine squared theta. And then maybe somebody looks at this and they go, oh, I remember Mr. Judson saying something about whenever you have a fraction within the fraction, you multiply everything by that least common denominator. All right, let's try that. So I'm going to multiply this by a cosine squared theta. I'll multiply this by a cosine squared theta. And then I'll multiply this whole thing down here by a cosine squared theta. Which means I have to distribute it to each of these. But let me just try this first. My goal was to get rid of this denominator, which I did. It cancels. And so then what I get is cosine squared theta when I multiply these plus sine squared theta. And I'm realizing right now that instead of distributing this to each, I really should stop right here because what's written inside the parentheses is the same thing that's written right here. So if I go cosine squared theta times sine squared theta plus cosine squared theta. Now we all know that when you add two things you can switch them around and it's still the same thing. So this is equal to this up here. And so as a result I can cancel this whole thing because I'm multiplying here with this whole thing. And again when I cancel I'm saying this divided by this equals 1. So now what I have is 1 over cosine squared theta, which that is equal to a secant squared theta, and that's what I was trying to get to. You guys see what I mean when I say that it's kind of like a puzzle, you just got to kind of work your way through and solve it. And those who like puzzles, they'll figure this out. They don't really mind. Those who don't like puzzles, this won't be our most favorite thing to do. Now, someone could have done this a different way. Let me just do Well, let me erase this and I'll work it out a different way. Somebody else might have looked at this and just said, well, isn't 1 plus a tangent squared theta, isn't that equal to a secant squared theta? And doesn't sine squared plus cosine squared equal 1? Which is that? And I go, yeah, good job. That was a quicker way to do it. So all those of you who saw this, good for you. You saw the quick way to get to it. But here's the thing. It doesn't matter how you get to the point where you show this is equal to that. If you take several steps like I did in the last problem, or you do it in one step. Now, sometimes people go, oh yeah, that just equals a secant theta because that's what they see over here. Well, no, that's not good. We have to have a logical reason as to why we're saying that. But yeah, sometimes people take 10 steps and sometimes people take 3 steps. And it just means somebody saw something different. Doesn't make it wrong. There will be multiple answers to all of these problems. All right, let's try one more. All right, so make the left side look like the right side. So now I can't change this to sines and cosines and then try and make this equal something with sines and cosines. I can't do that. I have to make this look like that. Now, I may want to change this to sines and cosines and work with it for a little bit and then find something that I can change back into this. I can look at this right here and say to myself, all right, what I'm really trying to get to is 2, and a cotangent is a cosine of theta over sine theta, and a cosecant is 1 over sine theta. So I'm really trying to get to 2 cosine theta over sine squared theta. That's what I'm trying to get to. And if I can get to this, well then there's my next step, and then that's equal to this. Okay, does that make sense? If I can make this side look like this, well then I know it's equal to this, and I know it's equal to this. All right. So let me just tell you one more thing. When you see 2 fractions that are being added or subtracted, and over here you don't see a plus or minus sign, that means somehow these 2 things got added together, which means we have to get a common denominator first, add those together, and then see where to go from there. All right, you guys go ahead and try this one. All right, so if I want to get a common denominator, we all remember this from fractions. If you're not sure what the common denominator is, just multiply the 2. So I'm going to take this over here and I'm going to multiply it by a secant theta plus 1. And what you do to the bottom, you got to do the same thing to the top. So secant theta plus 1. And then over here I'm going to multiply top and bottom by secant theta minus 1. And secant theta minus 1. Make sure we're using parentheses properly here because, if I don't write down parentheses and then I go and FOIL this, well, I'm not really doing what it says. I want to make sure I write it the correct way and do it the correct way. All right, so here's what I get. If I multiply this, I would get a secant squared of theta minus a secant of theta plus a secant theta and then minus 1. And this will give me the same thing. So this is our common denominator. In this numerator, I get secant theta plus 1. And over here, I get a secant theta minus 1. So looking at this, I know that these 2 things add up to 0. So when I add these, I have a 2 secant theta. When you add trig functions, it's just like saying x plus x is 2x. Well, secant theta plus secant theta is 2 secant theta. And I like seeing that 2 there because I see a 2 over here. See, one of the things I do is I constantly look back at this and what I wrote over here, and am I getting closer to this? Well, the 2 would suggest I'm doing something right. I just got to keep on going. Okay? All right, and then these 2 right here would add up to 0. And so what I have left is a secant squared theta minus 1. So again, I had mentioned this. Anytime you see an exponent of 2, right away we're starting to think about these Pythagorean identities. And I can see right here, if I move that 1 over to the other side, I would have a secant squared minus 1. So that must be equal to a tangent squared. So I could now change this to 2 secant theta over tangent theta. And then I look at that and I think to myself, I'm not really sure where to go now. Which means change the sines and cosines. Okay, so I now have 2 times 1 over a cosine theta. And then down here I've got sine theta over cosine theta. Oh, this is supposed to be squared, right? Secant squared of theta minus 1, that equals a tangent squared of theta. So this should be a sine squared theta over a cosine squared theta. And then to divide by a fraction, I would just flip it over and multiply. Now somebody could think to themselves, wouldn't I just multiply by the least common denominator again? And yeah, you could do that. They both accomplish the same thing. I've got 2 times 1 over cosine theta times, I'm going to flip this over and get cosine squared theta over sine squared theta. I'm already glancing over here and thinking, aha, I'm getting close. I'm going to cancel one of these with one of these. I still have one left. And so now what I have, I'm going to have to do this. I've got 2 times a cosine theta over my sine squared, but I want to see that written this way. So I'm going to write sine theta times sine theta. And then we'll just put a 1 there because when you multiply by 1, you still get the same thing. And there it is, 2. This right here is a cotangent of theta. This right here is a cosecant of theta. All right, so that one was a little bit of work, right? I mean, we were trying to get this to look like this, and it took 1, 2, 3, 4, 5, 6, 7 steps for this one. That happens sometimes. Some of these are longer than others. All right, that's what we have for today. Is trying to transform a left side of an expression into the right side. Whatever's here, make it look like that. All right, let me get you guys a homework assignment. All right, here we go. So assignment number 3. This is the end of week 3. This is our Friday piece. We've got page 309. We're doing 33 to 42. We'll do all of those. All right, you guys, there it is. You guys have a good week. Stay safe. Hope to see you soon.